And it is. All right, so is there, you had some homework on inverse transformations, and it involves several things. Only a handful of you have watched that video, which is totally your business. But are there any of those that we need to address from section 7.4?
I have to go back and watch it today. I completely forgot about it on Friday.
Let's look at 7.5, then finally bringing it all together. And I hope you're able to see that camera. I think you are. So we want to solve a differential equation using the Laplace transformation. And the first example is going to be very straightforward. Actually, you can look at that. If I look at just the original problem, that's really not even one I want to use a Laplace transformation for, right? I can look at that. I can visualize that characteristic equation. It's a relatively easy solution. The only thing we haven't really spent a lot of time, if any, is using these initial conditions to solve for C1 and C2. The Laplace kind of does it all for me. And really, when I want to use a Laplace transformation is when it's a non-homogeneous equation, something where it's equal to some function over here. But let's start with a relatively easy problem to begin with. So you'll want your handouts with the Laplace transformations on them and the inverses and all of that, because we'll need those things today. Okay. So for number 2, I've got y double prime minus y prime minus 2y all equal to 0. And then I've got 2 initial conditions. And this is problem 2 from page 382, if you want to include that. All right, so I want to take the Laplace transformation of everything. And I'm going to write it out for us this time. I want to take the Laplace transformation of the second derivative. And I'm just going through this original equation is all I'm doing. The Laplace transformation of the first derivative. And I think I'll go ahead and factor out that 2 if you don't mind. We've done that before. The Laplace transformation of just a y function. And then, of course, the Laplace transformation of 0 is going to be 0. Okay, so really, it's not all operators work like this, y'all, but really I'm taking the Laplace of this entire deal. Okay, so remember, I'm thinking about this original y function as some f of t. Don't let the notation bother you. Notation used to drive me insane when I was in your shoes. This is some function of t. Let it be y, let it be f of t, it doesn't matter. But when I transform that, that's where I get this capital F of s function. So just kind of keep that in mind. So I'm transforming it into functions of s. I'm going to work with those. Then I'm going to transform it back into a function of t. So let's find the second derivative portion. And so I'm looking on the handout with the properties. And I mentioned this the last time we met last Wednesday. I want to transform the second derivative. And this is exactly what it looks like. So let's fill that in. So I have an s squared. Let's see, let me use a couple of colors maybe. S squared times big F of s minus s times f of 0. And I have a condition for that, right? I've got this initial condition I can go back and use. And then minus f prime at 0. Those are little f's. Those come from the initial conditions from the original problem. This is a capital F in this position. All right, then I want to transform y prime. So I have a formula for that too. And here it is. S times big F of s minus f of 0. So And let's see, that's going to be a minus in front of all that, isn't it? So minus S times big F of S minus F of 0. And then, so all of this is Y double prime. All of this in these brackets is Y prime. And then I have minus 2 times Y, and that's the easiest piece of all. Minus 2 times the transformation of Y, which is just a big F of S. And all of that is equal to 0. All right. And I need to go back and use those initial conditions, but is there a question to there? So let me substitute in. Everywhere I have an F of 0, I'm going to plug in negative 2. Everywhere I have an F prime at 0, I'm going to plug in 5. So I have S squared, big F of S, minus S times negative 2, minus F prime, minus S times big F of S, minus F of 0, which is another negative 2. And you don't have to show me all these steps. I'm trying to show you everything there, but let's clean it up as best we can. So I have S squared, big F of S, plus 2S, minus 5, minus S, big F of S. So this is going to be what? Plus 2. This negative is going to make it back to negative 2. All right, so we've played this kind of game before. I want to gather up anything with an F of S term in it. So I'm going to hang on to this term, and this term. Anything that doesn't have an F of S, I'm going to take to the other side. So I'm going to kind of do all that in one step. Let me take the stuff across first, I guess. So if I take 2S to the other side, that becomes a negative 2S. Let's say I might have some like terms there. Do I have any like terms to combine? Negative 5 and negative 2 is negative 7 to the other side is plus 7. All right, so I've taken this and then these two things. Everything else, I believe, has a big F of S term. So I'm going to factor that out. And I'm left with S squared minus S minus 2. And so I'm going to divide both sides by that. And let me go one more step. Hopefully that's going to factor into S minus 2 and S plus 1, I believe. All right, ask me some questions to there. All right, so at this point, what I want to do is to transform it backwards. I want to do the inverse transformation of both sides. All right, so we know when we transform big F, we get back little f of t, which is, or in this case, y, which is actually what I'm looking for. So I need to take just a minute and deal with this right-hand side. All right, so let me just think for a moment. That I need to get it back as fractions. I need to get it in the form so that I can do an inverse transformation with it. I'm going to use partial fractions to do that. And let's take just a minute and work through our partial fractions. And you remember how partial fractions works? We want to choose convenient values for S. Remember, S can be any value mathematically. A and B are fixed. I want to choose any convenient value for S so that I can solve for A or B. So for instance, if I choose to let S be, say, -1, the purpose of that is to get this whole term to go away, to go to 0, right? So -1, that's going to be +2 plus 7 is a 9, equal to -3b. So it looks like b is -3. And likewise, if I let s be +2, that's going to be -4 plus 7 is +3, equal to 3a. I believe a is going to be 1. Which means I want to do the inverse transformation of 1 over s minus 2 and -3 over s plus 1. All right, so you can't see my whole piece of paper, but this piece is exactly what I had above the partial fractions. And so I used partial fractions to get it to be something that I could transform back. And so let's do that. All right, so on my sheet of inverse transformations, I'm looking at 1 over s minus 2, 1 over s minus 2, which is going to fit this form. So that's going to be e to the 2t power. And then likewise, I don't really need that -3. I can pull it out, at least in my mind. And that's going to also fit that same transformation backwards, e to the -1t power. So our claim is that this function, this f of t function, satisfies the original differential equation. And again, it took me a whole page to get there, but I mentioned earlier, this is not one I probably would have wanted to use that with to begin with. If I, from what we did last time, if I think about the characteristic equation, then you can see those solutions are matching up with the solutions that I got at the bottom of the page. What this method does allow me to find, of course, is the constants, the C1 and C2, given those initial conditions. But as I mentioned earlier, this is a problem that took me, just a handful of lines, even with the initial conditions to solve. than you doing the transformation. So this is probably not one I would want to use the transformation on, but it was a nice one to just get into the discussion. Let me take some questions on that. I did several things there. So who has a question?
Where did you find the original, just the Y piece? I see the Y prime or the F double prime, F prime, but where's just the
Let's look
F of
at
T?
number 4 on that same page. Y double prime plus 6y prime plus 5y equal to 12 E of t. And then I've got initial conditions of y at 0 is equal to -1 and y prime at 0 is equal to 7. And again, y'all, that's the same thing as f of 0, f prime of 0. The sheet of transformations that you got are in terms of f of t, not y, but it's all the same stuff. All right, let's do it. Let's transform everything, including the right-hand side. And just keep in mind what we had to do before was to find the characteristic equation, and then we had to use whatever our favorite method was. Undetermined coefficients would be a good one in this case, but whatever to solve the whole thing, and then go back and find the C1 and C2 using the condition. So I think the Laplace is going to be a little bit nicer here. All right, so I transform everything. So the transformation of this entire problem, and I guess I'll write it out. Transformation of y double prime plus 6 times y prime plus 5 times y equal to 12 times the transformation of E of t. Okay, so four things that I need to transform. All right, and for y double prime, I'm still going to use the same formula, but as we do it this time, I'm going to go ahead and substitute in for f of 0 and f prime of 0. All right, so I have s squared, big F of s, minus s times f of 0, which was -1, minus f prime, which was 7. Right. Plus 6 times the transformation of y prime, which is s f of s, minus f of 0, which is -1. So minus -1 is positive. And then plus, these are 5s, not s's, plus 5 times the transformation of y, which is just this f of s. That's not on that list of transformations, but again, that's what we've been doing. So don't make that be a mystery. And then when I transform e of t, e to the 1t, that's going to be the same as 12 over, or 12 times this next fraction, s minus a, in this case, s minus 1. Right, any questions to there? All right, so let's clean it up. Just watch your arithmetic and your signs. just glance back at mine and be sure I hadn't lost a sign or anything of that nature. All right, so one more time, I've got to, I need to gather up everything with the f of s term and keep it on the left-hand side. Everything else is going to go to the other side. Let's see, maybe I've got some. I wonder if I want to combine it now or later. I guess later. So I have big F of s times, when I factor it out, s squared plus 6x plus 5. And on the right-hand side, let's see, I'm going to have an s and a minus 1. No, an s and on the other side, a negative s and a plus 1 in it. Sorry. Double check my signs. I'm worried I've lost something. I'm looking on my screen to be sure. Okay, so the what's in brackets will factor. On the right-hand side, I'm going to need, unfortunately, a common denominator. And I think I'll just go sideways if you don't care. Let me find the one other color. Okay, so when I full out here, I have negative s times s is negative s squared. Negative s times negative 1 is positive s. 1 times s is positive s. And 1 times negative 1 is negative 1. Which becomes negative s squared plus 2s plus 11 all over that same denominator of s minus 1. All right, any questions about my algebra? All right, so finally I get this numerator, and I've got 3 things in the denominator now. I've got an s minus 1, an s plus 1, and an s plus 5. And once more, I'm going to use my partial fractions. And in the interest of energy, you can do partial fractions. I would choose s to be positive 1, s to be negative 1, s to be negative 5 when you have that new equation to solve. But let's just pretend that we've solved it because I've worked this one out. And I got that a was 1, b is negative 1, and c is negative 1. So partial fractions, exclamation point. You can go through that. So we have then that our function looks like 1 over s minus 1 minus 1 over s plus 1 minus 1 over s plus 5. And I can transform each of those back. And so I believe, again, if you need some things in your notes, this is the inverse transformation of this entire equation. I'm left with 1 times e to the 1t minus e to the negative 1t minus e to the negative 5t as my solution. So for problem number 2, it didn't seem like the Laplace transformation was a very useful technique, but in this respect, it's an incredibly useful technique, at least in my opinion. I can look at this original problem. I get it on the screen. I can look at this original, the homogeneous case, and solve it pretty easily. It's this piece that would take a little bit of effort and energy to do, but this does it all for me, and it finds the C1 and C2. They both happen to be 1 in this case. I guess 1's for here, but allows me to do the whole thing in what I think is a relatively easy step. Ask me some questions.
I think you muted yourself.
Everybody is quiet this morning. Okay, the hardest part of these problems, y'all.
I don't think he can hear us. Hey, Dr. Ross. Oh.
Please tell me I haven't been muted this whole time. Oh
no, just the last like 20 seconds.
Have I been muted forever?
No, just 20 seconds.
Good. I guess when I came back on, it was muted. My apologies. I got worried. What questions do you have about any of that so far?
That was pretty easy. I don't think you can hear us either.
All right, so I've assigned just a handful of homework problems with those that are relatively easy. The hardest part of that is partial fractions, generally speaking. If you haven't done the homework on the inverse transformations, you need to do that first before you tackle these, because that can be a little bit involved. I don't think these are involved necessarily. Okay. So that ends our material for this class. And so you have a test, I believe that I've got it posted, but I believe it'll open tomorrow, and then it'll be due Friday, and just submit it like you did last time. In a perfect world, one PDF is the best case, but I realize some of you had some trouble doing that, which is fine. You know, take a picture and upload the picture if that's what you need to do. Whatever you can do to make it happen, you know, feel free to do that. Don't spend a lot of time trying to upload something or get it to be in a form just for my benefit. Send me what you can, okay? So that'll be due Friday, and I'll try to grade those by the beginning of next week. And then we're going to take a final exam in this class, and there's a final exam posted, a final exam review posted with solutions in Canvas already, and it should be available. If it's not, send me a message, and I'll be sure that it is. And then I think I said this in your Canvas message, I'm gonna let you go ahead and probably begin that final. And I gave you some specific dates on open and close on that. I know, Vince, you said last time about being comprehensive and so forth, and I get that. I also get that we're all kind of using the honor system. So if you, you'll have your notebook to do that with. So anyway, that is our plan for this class. What questions do we have?
I have one question about calculus.
Okay.
So I've been doing the videos, taking notes. Do I need to also go back and do every single homework problem? Do those have a due date or?
They don't. So again, my philosophy, at least at this level, is homework is just practice. So if you can do the ones that I've assigned, that's the ones you need to work through. And then I don't have that in front of me, so I don't remember. We have a test next week in there, I think, if that's correct. So I'll post a test review just so you can do it online and practice that idea and not have to worry about, it won't be a paper and pencil test. And that's a little bit harder, I think, to do that. But that is our plan in there.
I know that's how you're taking attendance, and I don't want to get to the end of this and then get dropped because I didn't do a couple of homework.
Y'all, I'm not dropping any of y'all. If you doing halfway anything, I'm not going to do that to you at the end. I would never do that. We all kind of figuring it out as we go. I read somewhere the other day, this is not really, not me in particular, but just in general, this is not really online teaching, it's emergency teaching, and that's actually the case. So we're just doing what we can to get through. So don't stress with that.
On that memo that you sent out for this week, it says that test 3 Cal 4 is due by 4/24, which is this week at midnight. But now you just said that test 3 is next week.
No, I don't. I said I didn't have it in front of me. I honestly don't remember. I've posted so much, I can't remember what I've done where. So if that's the case, then,
neither can we.
Right, I know. And so if that's what I wrote, that's probably what I meant. If y'all want to bear with me, I'll try to pull it up and be sure. Let me look.
I just looked on Pearson right now, and it shows that by 4:23 at midnight, you have to have test 3 practice done, but there's not a test 3 test showing up yet.
Test 3 will open another day. I'll tell you. Hang on, let me get mine pulled up. Y'all can't see what all I've actually got on there, and it's just set to come on and that kind of stuff. Bear with me. Let me share that. So yeah, today is the 20th. And so, and you don't have to do this today, but that test actually will open on tomorrow and is due on the 24th. I don't know why I didn't just put them all at the same time, but I would like to maintain a little integrity with the class. Very little apparently, but where you would do the practice test and then take the test. Other than that, at any rate, if you do it all today, you're great. But that will open then tomorrow, and that would need to be due by Friday. So do take the practice test. You can take it multiple times. Take the practice test before Thursday is when it will close. What other questions do we have about that? There's a survey. Have y'all seen that on Canvas to decide and commit to your plan for the final exam in calculus? I think again, I've posted so much and so many different things, but I think it's going to be open through next week. So you should see your grade. Give me a chance to look at the grades in case we've all bombed it. Let me correct any of that we need to, but anyway, you should see your grade and have a sense of where you stand in the class to be able to make a commitment on there. Other questions?
Probably a dumb question. For Cal 4, there's no way for you to see work done on those problems, but what I was finding on the homework is that one sign just gives you a wrong answer, period. Is there any way that we could submit work for that?
Absolutely, and I can always go back and hand grade that. So if you think you're going to fall into that, you might just make a point to work it in an organized fashion where we can go back and look at it and hang on to it. And you can't review any of that until after the test closes. So, take the test, and then on Saturday or after midnight, Friday or whatever, Saturday or whenever, go back and look at yours. And if you see a discrepancy, absolutely send me a picture of your work. Tell me which problem to look at. I don't mind going back and looking at any of that.
Okay.
And some of those problems, I think, are like, I can't remember if it's Cal 1 or Cal 4, where it's sort of kind of like the homework where you maybe had multiple parts to answer as you go. So that may help you organize your thoughts. What else?
Okay.
The homework for this stuff is going to be on our homework sheet.
4D.
Yeah, the 7.5.
Yes.
There's going to be the whatever problems are on there.
That's correct.
Okay, I don't have it in front of me. I was just asking.
I don't either. So, but yes, it should be there. 7.5, I think, 82. So be sure you're working through those. And again, the test for this is 10 questions, but it's some of all of it. So, but I don't think none of this is very bad. The partial fractions business gets a little involved. Y'all can do any of that. It's not going to be difficult. Anybody else?
I'm good.
I know that if you did the Cal, like I know in your class you have a drop grade, or not a drop grade, but a replacement grade for your final.
Correct.
So if you decide not to do I don't know exactly what the choices are for Cal because it hasn't opened up yet. But I know there's the choice of taking the final and not taking it.
Right.
So if you didn't, you would avoid the replacement, correct?
I think the way it is, the way I've worded it is, if you just take the 3 tests, then I'll duplicate your highest grade for a 4th test, and I'll average those 4 numbers together. If you opt to take the final, then the final will count 25% per the syllabus, and will also replace a grade if necessary.
So DE automatically will do the replacement stuff.
We're going to follow the plan on the syllabus for DE. That's correct.
Okay, that makes sense. I was just trying to get
I'm trying not to violate the agreement with the syllabus. I don't think that's fair to y'all. Just suddenly change plans. But in calculus, I'm okay with changing plans if it helps you, so you make a choice that's right for you, and I'll certainly be okay with that.
Where's the chickens at?
We actually had baby chickens today. I should have met in the dining room. They're sitting in a box in the dining room. So,
get them.
I don't know how many she's got. I don't fool with none of them.
I doubt it. You're going to get off this and go play with them.
Exactly. Yes, I just love the chickens. We are getting 18, 20 eggs a day. So if y'all need eggs, let me know. I think this is the last time we'll meet together as a class. I'm available, y'all, if we need to meet and talk about some things. By all means, send me an email and I'll be glad to do that. But we won't meet again. We'll just work virtually from here on out since it's just those last 2 assignments. And then like we've been doing in Cal 4 at least. Okay, so I've enjoyed the semester with all of you. I wish you the best of luck. If I can do anything in the future, don't hesitate to ask. I know you'll need some letters of reference and that kind of stuff. That's not a problem. Just if you'll tell me on the front end, that'll be helpful. But happy to do anything that I can. Okay. All right, group. Enjoy the rest of your Monday.
You too. Have a good one.